A common challenge among students is finding the right place to study. Searching for the perfect study environment can be a trial and error process as there are many options: libraries, cafes, lounges, classrooms, or parks. One popular choice amongst UCLA students is the Blue Room, a small study room located inside one of UCLA's newest buildings, the Hedrick Study. Functioning as a workspace for many students, this room is lit across all borders of the ceiling with a blue lighting fixture that illuminates the entire space with a blue hue. It features comfortable chairs, a black starry ceiling, and a peaceful ambience. Why might this unique environment be so well liked among students? Could the blue lighting have a positive influence on productivity, focus, or the ability to retain information? Before revealing the effects of blue light on memory, it is important to understand how colored light impacts people physiologically. Colored light is modulated in humans by a photoreceptor system consisting of specialized cells in the eyes that convert light into signals, triggering brain activity and processes that elicit physiological responses. This photoreceptor system is closely linked to the circadian rhythm, an internal clock that the body uses to regulate the sleep-wake cycle. Brainerd et al., 2008. Naturally, circadian rhythms are sensitive to light exposure, night and day, but blue light has the greatest effect on the photoreceptor system and circadian rhythm. Burson et al., 2002. The modulation of the circadian rhythm system due to blue light exposure can alter and increase an individual's feeling of alertness. For example, Kajokan et al., 2011, explored people's physiological responses after exposure to blue monochromatic light for 2 hours. Results from saliva samples revealed that melatonin, a hormone that regulates the sleep-wake cycle, was suppressed by the brain. Normally, the release of melatonin in the brain is associated with darkness and causes feelings of drowsiness. Bauer, 2020. Therefore, the suppression of melatonin may lead to enhanced alertness and attentiveness. Kajokan et al., 2005. As a result, blue light's ability to increase some cognitive abilities makes it an attractive environmental aspect for those seeking productive studying. When studying, long-term memory is often the focus for many students since their goal is to retain and later retrieve as much information as possible. However, working memory, which involves the active retention of smaller pieces of information and preparing them for long-term storage, is an important component of long-term memory and the studying process. Specifically, working memory facilitates comprehension, reasoning, planning, and problem-solving, and is also important in the ability to execute cognitive tasks as it directly helps with concept formation, control processes, and mnemonic strategies. Cowan, 2014. Therefore, when looking at the effects of blue light, it can be insightful to examine its effects on working memory. To explore the effects of blue light on working memory and brain activity, Alkaye et al., 2016, investigated participants' performance on a cognitively challenging task after either being exposed to blue light or amber light, to imitate natural lighting, for 30 minutes. Immediately after exposure to the light, participants were examined under functional magnetic resonance imaging, fMRI, as they completed a working memory task. Blue light conditioned participants had faster responses and exhibited greater task performance compared with participants exposed to amber light. The fMRI also revealed increased activity in the ventrolateral and dorsolateral prefrontal cortex, regions known to be associated with working memory. Curtis and Desposito, 2003. Thus, exposure to blue light can enhance task performance and increase activation in regions of the brain associated with working memory. Similarly, Van Duyl et al., 2007, tested short exposure to blue light in comparison to light of similar wavelengths, violet and green. The examination of these different colors is important in investigating if humans are particularly responsive to blue light's specific properties. Each participant was exposed to all three of the light colors in a randomized order across 3 sessions. Each session consisted of 50 seconds of alternating colored light exposure followed by 15 seconds of darkness, repeated 10 times. During these sessions, participants were asked to perform a working memory task while also being examined via fMRI. Compared to both violet and green light, participants exposed to blue light were faster and exhibited higher accuracy on the working memory task. Additionally, during periods of blue light, the middle frontal gyrus, known to be associated with working memory, exhibited enhanced activity. Together, these results suggest that the brain is most responsive and sensitive to blue light and that there may be cognitive benefits of blue light over other colors. While we are sometimes exposed to blue light in our environment, the screens of our electronic devices may also expose us to blue light. With the growth and development of technology, more aspects of learning, education, and the workplace have been moved to online platforms. This shift increases the amount of time individuals spend on blue light emitting diode, LED, electronic devices such as computers, smartphones, and tablets, Hattori et al., 2017. These are all common sources of blue light due to the screen's LED backlight, which provides brightness to the screen, Bucker and Grandee, 2020. To investigate the effects of blue light emitted from screens, Kajokan et al. 2011, exposed participants to 5 hours of screen light, one LED screen, blue light emitting, and a non-LED screen. Kajokan et al. Then examined participants' working memory and found enhanced performance in those who were exposed to the LED blue lit screen. Overall, these findings further reveal the potential of blue light to improve memory. Ultimately, blue light may enhance working memory, attentiveness, and facilitate learning. Specifically, recent work suggests that working memory can be enhanced in a blue-lit environment, potentially encouraging educators to incorporate blue light in the classroom to help facilitate learning, attention, and productivity. Based on the work discussed here, UCLA's blue-lit study room is one that other universities, education facilities, and learning spaces should consider implementing. Even at home, finding a way to incorporate blue light into workspaces through a blue light bulb or blue LED lights may be beneficial for productivity, alertness, and memory. Therefore, when looking for a place to work or study, remember to go blue.